As global warming moves into the forefront of domestic and international agendas, the initiative to reduce carbon emissions and reliance on foreign resources is propelling the production and use of biofuels. Bioethanol and biodiesel are the primary biofuels today and can substitute or be blended with gasoline and diesel to reduce toxic air emissions. Biodiesel is produced from domestic, renewable resources and is biodegradable, has low toxicity, and is generally free of sulfur and aromatics.
Biodiesel is made through a chemical process called transesterification. This reaction combines vegetable oils and animal fats with an alcohol in the presence of a catalyst. The resulting biodiesel contains both soaps and glycerins. These soaps and glycerins are separated out through gravity. The crude biodiesel remaining still contains some impurities. These impurities need to be washed out further with either a wet wash process or a dry wash process.
The difference between wet and dry washing of biodiesel is that the wet process uses water to remove the impurities. Water is passed through the biodiesel several times and the impurities absorb into the water, which then settles and is separated from the biodiesel. The dry process replaces water with an adsorbent. The adsorbent removes the impurities and it is separated from the biodiesel. This reduces the production time, it reduces wastewater, and it reduces the operating cost.
As with any developing industry, biodiesel production technologies are evolving. A variation of the dry wash process utilizes resin instead of magnesium silicate.
By using a dry ion exchange resin like the Purolite PD206, biodiesel manufacturers are able to remove the largest amount of impurities from their crude biodiesel. The technology actually provides a simple, cost-effective, low-energy method for purifying their biodiesel. The Purolite PD206 actually replaces inorganic absorbents as well as multiple stages of water wash in the waste associated with the use of those technologies. The Purolite PD206 allows for higher yields of biodiesel by reducing processing time.
This spherical plastic polymer assists efforts to arrive at a clean, renewable fuel source.
PD206 helps biodiesel manufacturers produce product that meets specification that is set by the American Society of Testing and Material, or ASTM, or the European equivalent, EN. PD206 used before demethylation produces cleaner biodiesel as well as improved production economics.
To be considered fuel grade, biodiesel must adhere to strict industry standards in order to assure proper performance. The fuel's performance heavily depends on the purity of the final product and the achievement of ASTM or EN specifications.
It is important to remove contaminants from biodiesel to optimize a diesel engine's life. It is essential to monitor the impurities in the biodiesel. When fuel is dirty, it creates unnecessary wear and tear on the engine and produces excessive emissions. The use of Purolite's PD206 to purify the biodiesel maximizes the removal of the contaminants.
According to the National Biodiesel Board, there are currently 165 companies that have invested millions of dollars into the development of biodiesel manufacturing plants and are actively marketing biodiesel. The annual production capacity from these plants is 1.85 billion gallons per year. But there is some concern about the environmental impacts created by the process of producing biodiesel.
Although biodiesel is a cleaner fuel than petroleum diesel, production of biodiesel still results in the production of waste streams, liquid and solid waste streams. PD206, which is a regenerable resin, helps to reduce in the solid waste production. This material can be returned to Purolite for regeneration. Biodiesel producers can then use this material multiple times over several years before it needs to be disposed of. This material reduces operating costs, it reduces solid waste generation, and lessens the environmental footprint.
As a cleaner energy source than conventional carbon-based fuels, biodiesel has a closed carbon cycle. The carbon dioxide released into the atmosphere when biodiesel is burned is recycled by growing plants, which are later processed into fuel. According to a biodiesel lifestyle study jointly sponsored by the U.S. Department of Energy and the U.S. Department of Agriculture, Biodiesel reduces net carbon dioxide emissions by 78% compared to petroleum diesel.
Petroleum-based biodiesel has a much greater adverse impact on the environment than does biodiesel. Petroleum diesel contains sulfur, and when sulfur is combusted in an engine, it creates harmful emissions. However, biodiesel has a much lower sulfur content. When mixed into the nation's fuel supply, biodiesel will lower the content of sulfur and thus reduce harmful emissions.
As the fastest growing and most cost-efficient fuel for fleet vehicles, the biodiesel market is also expanding to the public sector.
With biodiesel as part of the solution mix to the world's current energy demands, Purolite is committed to providing economic and environmentally friendly solutions to the current and future energy challenges. There's an exhaustive amount of research being conducted in the alternative fuel industry today. Purolite has also committed a tremendous amount of R&D efforts to this solution. This situates Purolite excellently in the biodiesel sector.
If you would like more information on the Purolite Company, call 1-800-343-1500 or visit them online at www.purolite.com.